Welcome to this full, comprehensive, in-depth, from zero to hero, from beginner to expert, from broke to multimillionaire crash course where you will learn how to develop upgradable smart contracts. You can develop upgradable smart contracts using a lot of different patterns, but the most used one is the delegate call proxy pattern. This pattern uses the delegate call function. What a surprise. So let's see what is the delegate call function and what does it do. The delegate call function allows you to execute code of the Kali contract in the context of the color contract. How does this work? Let's say you have a color contract and a Kali contract, and you have a variable here, num, and you want to update this variable. So instead of calling a function in this color contract, you can use the delegate call function to call the setNum function of in the Kali contract, and this way it will take the code from this contract and it will execute the code as it was in this color contract. And this way a contract can load any code dynamically from any other contract using the delegate call function. The storage, the address, the message.sender, and the message.value will still refer to the color contract. You would do this because this way you can save all the state in one contract. We'll call this the proxy contract, and you can save all the logic in different contracts. So all the data of the users is saved into this proxy contract, and all the logic is just saved in other contract. And this way you can upgrade your smart contract. Let's say this proxy contract was using the first time it was deployed and the last one. It uses this logic v1 contract, but then you want to update the logic of your contract. You would keep all the state in this proxy contract, and you would just upload a new contract, and you would just point this proxy contract to the new logic contract. And you would do this just by adding a address here into the proxy contract that points to this new logic v2 contract. This way we keep the entry point in one contract, so the address of the contract of the proxy contract the people use stays the same and the logic is still updated. So let's see an example. First, I've developed the proxy contract. This is the contract that users will interact with. This contract just saves a number variable. It has an owner, and you'll see why in a second. It stores the address of the logic contract. This is important because later we'll upgrade this to the version 2 logic contract. Once we deploy the contract in the constructor, I'm just setting the owner, the person that deployed the contract. We have a set number 1 variable, a main function, that just updates the number 1 to whatever value we pass here. Don't worry about this for now. We have a upgrade function. This one takes in the address of the logic contract and it just updates it to a new address. And this one can call only the owner. This is a trusted owner that has access to this address, or better yet, because we don't want to make this centralized and where only one person can have access, better yet is to have some sort of governance here. This only owner modifier just makes sure that this is where the magic happens into the set number 1 function. Here we are just using the logic contract address, and remember we can update this, and we're calling the delegate call function on this address. And once you call the delegate call function, you can pass it the function that you want to call from the other contract. But we have a logic contract. This is the version 1. We'll update this to version 2. We have a variable here as we had here, and we also have a set number function that does the exact same thing, and we have a set number function that updates this number variable. So whenever users use the proxy contract and they want to set the number, they will call this we'll call delegate call function with this function that's from the other contract, and that's how we'll update the number that's in here. So let's save this, deploy the contract now. First deploy the logic contract, then we'll deploy the proxy contract. And in the proxy contract, first we want to call the upgrade function with the address of the logic contract. Now if I want to update my number, I'll just pass in 5 here, click on set number, and if I see the value of the num1 variable, it's 5 now in my proxy contract, and in my logic contract is still 1. So this is how the delegate call pattern works very simply. So now let's say that you want to update the logic, and instead of updating the number to whatever you passed in here, you want to update to the double of that number. So let's say you want to update the logic. I'll just add in ×2 here and change my contract from version 1 to version 2. I'll try to mimic a real world scenario here. Let's say where the proxy contract is already deployed, the version 1 is already deployed, but you want to now deploy the new version 2 contract, which I'll do right now. And here we have the logic v2 contract, and now all you have to do to point the proxy contract is copy this address of the logic v2, paste it here, call the upgrade function in the proxy contract, and now when I do the same thing, let's say I want to set the number to 5, I call the set number function, and if I check my num1 variable, you can see it's 10 now because we've changed the logic. And this is how you would update your proxy contract logic without actually deploying a new contract. And just for reference here, I believe the best way to do this proxy pattern is to do all the delegate calls inside this fallback function that you would have in the proxy contract in order to be flexible enough to allow for bug fixing and adding new methods. And if you didn't know, this fallback function gets called, it's a native function in Solidity and gets called whenever you call a function in the smart contract that doesn't exist. And this message.data that we're passing is just the raw data of the transaction. So it's encoding of the function signature, I think selector, and any parameters that you're passing to the function. And now to the fun part. Let's see how you can misuse this delegate call proxy pattern. Let's say we have a number2 variable in here into the logic contract that we want to update with the set number2 function. And in the proxy contract, of course, I want to add in this num2 variable, and in here I want to delegate call, in my proxy contract I want to delegate call this set number function, which I'll do in the exact same way I called the set number1 function. So let's deploy the proxy contract and then the logic version 2 contract, and let's now try to update the number2. I'll just say 5 here, call the set number function, and let's see what we have. And let's now make sure to upgrade our smart contract, copy the logic2 address, paste it here, call the upgrade function. Now the logic contract address is the correct one, and let's now call the set number2 function. I'll try to update, I want to update my number2 to 5, call this function. Let's see if this resulted in num2 being 5. And if I call num2, it's 0. And if I check my owner variable, that's actually 5. Why is this happening? And this brings me to my lesson about storage collisions. Whenever the proxy contract calls this logic2 contract, this code is executed in the context and proxy contract from the caller contract. And what we have here, the slots are actually not the same. Here, if you didn't know, a contract storage is stored into slots, each being 256 bytes. And for this to work, you have to have the storage layout the same in both the proxy and logic contract. And we don't have the same storage layout here. We have the num here. That's correct. We have the num here, but we have num2 here into the second slot. And we are storing the owner variable here. So whenever we now update this number, we are overriding this owner variable instead of our num2 variable, which is stored at the 4th slot instead of the 2nd, as in this logic contract.